So today we are starting new unit 4. So very first topic of the unit 4 is physical and chemical changes. So any idea what is a physical change? A physical change in state, yes. And what's a chemical change? Yes, breaking of IMF. Very good, Amodita. So a physical change is change in state due to breaking of IMF. That's very important. Intermolecular forces of attraction, IMF. And what is a chemical change? Change in chemical composition. Change in chemical composition means breaking covalent bonds, chemical bonds. Very good. Perfect answer. These are the physical properties. All physical properties are governed by IMF and by physical changes. Temperature, color, melting point, electrical conductivity, all these are controlled by physical changes and by IMF. And these are controlled by chemical reaction, chemical nature. What Amodita has given me two answers here, which is really very good. And this is something which you will be tested in every examination. During physical changes, we are breaking IMF. You have done IMF in unit 3. During chemical changes, we are breaking. You remember one word, intra. Intra and inter. We are breaking intramolecular forces. And what is intramolecular force? That is the force within the molecule, within the atoms, in a molecule. This is a bond. So you are breaking bond during chemical changes. You are breaking IMF. IMFs are attractions among the molecules. Big thing. So you'll be tested for it. Okay, now there is a quiz based on it. Please try to do that quiz. So what do you think? These are physical changes, all of them? This heating, this is heating. So heating is a physical change. Is this a physical change or chemical change? This one? It's a chemical change. This is a physical change, solid, liquid, gas. So these are very simple questions. But when you are going to do the quiz, you will learn more. So do the quiz, think very strongly and intensely there and try to answer the questions because there are different types of questions on physical and chemical changes. Dissolution. Now you can see in dissolution, there is solid here and finally the solid is dissolved. So Anaya and Mayank, are you saying dissolution is chemical change? Are you saying that? Is it a chemical change, children? Solution making is a chemical change? No. Oh, this was for the previous one. Yes. Dissolution is a physical change. Actually, sometimes we call it as semi-physical, but more it is a physical change. Dissolution means making of solutions, homogeneous solutions. Solution. So what is happening, like this is NaCl, let's say, Na plus, Cl minus. You can see the lattice here. Then Na plus, where is Na plus? This one, smaller one is Na plus. You remember? Cations are always smaller than anions. Periodic trends. Cations are always smaller than anions. Yes, Mayank, Ananya. Do you remember from the periodic trends? This Na plus has how many electrons? Okay, so please be very solid with your periodic trends. So here Na plus is surrounded by water molecules. What is this called as? This process where Na plus is going to be surrounded by hydration. Yes, we have done it so many times. This hydration is exothermic, endothermic. Yes, Akash? It is exothermic. Akash, you are there? Exothermic. This is breaking of the latex, which is endothermic. Then this is hydration process in which the solution is made. Can you see how every Na plus and Cl minus is surrounded by water? That is exothermic. So dissolution is a kind of semi-physical change. It's a semi-physical change. Some part is chemical change, like NaCl is broken down into ions, but basically it is categorized as physical only. So please do the quiz. So this is dissolution. What happens to the size of the ion after hydration? Like for example, Mg, here I'm asking some questions from unit 3. If I give you Mg2 plus, Na plus, which one is smaller in size? This is a very good question. Which one is smaller in size? Look at the periodic table, look at the effective nuclear charge. Which one is smaller? Mg2 plus is smaller. Now I'm adding water into them. After adding water, they will hydrate it like this. Which one is more heavily hydrated? Mg2 plus, very good. That will be more heavily hydrated. After hydration, which one will become more smaller in size, more bigger in size? Heavily hydrated means many water molecules around it. So who will become more bigger in size now? Yes. So remember, Mg2 plus in the gaseous form, isolated form, is smaller than Na plus. Periodic trend, effective nuclear charge, more attraction. But Mg2 plus, can you see the difference here, children? AQ is greater than Na plus, and you should know the reason. Because this is going to be more heavily hydrated than this one. Who will move slowly in the solution? Which ion will be moving slowly? They are free ions now, hydrated by water. So out of these two, which one will move slowly? Yes, the bigger one, the bigger, massive, they have less kinetic, they have less velocity, so they will move slowly. Okay, so that's the process of dissolution, which we have already understood. Now hydration is clear. Can you see how Na plus is hydrated? Cations heavily hydrated by oxygen. This is oxygen. These are hydrogens. See orientation. Orientation is very important. This is anion. What is this? Hydrogen, hydrogen, hydrogen. Yes. Okay. So now this is hydration. What is dehydration? Dehydration is removal of hydrate means adding water. Dehydration means removal of water. Not from the ions, Akash. Not from the ions. That's totally evaporation. This dehydration, if you remember, we did one quiz also in unit 1. We did hydrated salts. Hydrated salts. We did plenty of questions on them. Go and do the quiz again. It's very interesting quiz, mathematically very strong quiz, mole concept, everything. If you remember this quiz from unit 1, like this one is hydrated salts. This is CuSO4 5H2O. This is called as water of crystallization. I told you all these words there. Water of crystallization. So when you are heating, can you see you are heating it? Heat, you can see here. So when you are heating it, what is happening to the color? It's decolorized because this CuSO4 5H2O is blue in color. This is the one who is blue in color. And after heating, is getting converted into copper sulfate and water evaporated. Water has, this is the solid. This solid you can see. And where is water? As vapors. This is white in color. What is this process called as? Dehydration. So you can do dehydration by using heat. But generally in organic chemistry, we are doing dehydration by using some acids also. Some compounds, they act as good dehydrating agents like P2O5, H2SO4. It's not needed for your level, okay? So just ignore it. They are dehydrating agents. When you add these compounds in some substance, it will remove all the moisture. You remember how when you purchase a new water bottle, there is some kind of a gel in a small packet is there in the inside the bottle. What is the aim? To control the water moisture, to remove the water moisture from the bottle. So they are dehydrating agents. I think that is silica gel. So silica gel will remove water vapors from the bottle which is totally closed. You're understanding this, children? So use the words which I wrote here. I'm just bringing it back. Have a look. Have a look. I want you to use these words now. Na2CO3, 10H2O. What kind of salt is this? It is a hydrated, please type here, hydrated salt. What is the water of crystallization in this hydrated salt? These are fixed values. Water of crystallization. This is beautiful. These are crystals. Can you see the difference here? This is crystals, sharp edges, well-defined shapes, and this is amorphous. So this is crystalline in form. But actually this one is also white in color. No color, white. When I heat it, what happens? Heating. What happens? Yes, it becomes anhydrous salt. Very good, Mayank. It will become Na2CO3, anhydrous. And this anhydrous salt, this is crystalline. You know the meaning of crystalline? Sharp edges like this. Anhydrous is, anyone? Do you know the word? Anhydrous salts are amorphous. They don't have sharp edges. And where the water has gone? Evaporated as gas. What is this process called as? Mm-hmm. Anaya? Yes, dehydration. Is it a physical change or chemical change? It's a physical change, no change in chemical composition. Do you think this hydrated salt, this anhydrous salt, they have the same molar mass or different? Different molar mass. If you remember the quiz which we did in Unit 1, there we were working with the molar masses, moles. We were calculating these numbers. These numbers we were calculating. So try to do the quiz again. Now we are going different types of chemical reactions. These were physical changes. All these dissolution, okay, heating. Now we are doing different types of. I'm just going to teach you the names here, and then after that we can keep doing reactions, questions on reactions. You keep identifying what type of reaction is this. Synthesis or combination. The condition for synthesis reaction is you should get only one product. Only one product. There should not be more than one product. Only then you can call that reaction as a synthesis reaction. Because we don't want multiple products there. We want only one. So if I say H2 reacting with O2, giving you H2O, can I call it as synthesis reaction? Combination reaction? Can I call it as combination reaction? Yes. CaO plus CO2. Can I call this as synthesis reaction? Two products, two reactants combining to give one product is combination, synthesis, because I'm not getting any byproduct. So I'm not getting mixture of products. Oh, C. Yes, Akash. Thanks for correcting me. A plus B giving you C. This is again synthesis. What do you think for this? Can I call this as synthesis reaction? Synthesis, yes. Do you know this compound? Can you name it? Yes, ammonia. Is it polar or non-polar? What kind of IMF are there in ammonia? Mm-hmm. Very good, Amodita. Very good, Akash. Good. Excellent. Okay. Now, okay, let's see the reverse of these reaction. Now I'm writing the reverse of the reaction. Just write it other way around. When you reverse a synthesis reaction, it becomes a decomposition reaction. Like here you reverse this. You have to practice few important decomposition reactions. Remember, okay, let me take you on the next slide and I'm going to teach you a few things which are very important. Oh, this is representation of synthesis, right? Can you see how sulfur is represented by yellow color? Fe is here. This is before the reaction, before. And this one is after. This is called as representation of reaction. So in this first category, is there any limiting reactant? Is there any reactant which is left in excess? Just compare picture 1 and 2. No. So both of them are limiting. But in second situation, compare picture 1 and 2. Is there any excess reactant? Yes, Fe is the limiting. Excess is sulfur. Anaya, you're not answering. Excess is sulfur. Anaya, you're there? Okay, start answering, dear. You're understanding this? They all are identifying the limiting reactant and excess reactant from this picture. Limiting reactant we have already done earlier. Okay, check here. Okay, what's the reaction? First, let's write on the reaction. Yellow is sulfur, Red is oxygen. So reaction is sulfur plus, yes, sulfur plus, see this picture, O2, giving you sulfur dioxide. So which one is the correct representation? Count the sulfur atoms. 1, 2, 3, 4, 5, 6, 7, 8. Count the oxygen atoms. 1, 2, 3, 4, 5. This is initial. Before reaction, initial. This is 0 initially. Can you tell me finally? Just complete it here. Finally, how much oxygen should be there? Mhm. Let's complete it here first. Then we'll see the picture. You know, they are reacting 1:1. So 5 oxygen will react with how many sulfurs? 5. So how many are left unreacted? 3. What happens to 5 oxygen? It will become 0. How much SO2 is formed? How much SO2 is formed? 5. Which picture is good? Okay. But actually, this representation is not correct. Is this SO2? SO2, you remember the Lewis dot structure? Yes, Akash. No, no, like this. Yeah, okay, you cannot draw it in that way. It's bent. It's polar in nature. Bent. 3 groups. So this picture is not good. So it means we have to put 3 sulfurs here. That is not shown. This can be right, right? Bent. Can you see how it is bent? It's not good. It's not good. But yes, there is error here in the picture. 3 sulfurs should be here. So I'm doing correction. Are we okay with this? Okay. So this picture representation is very important. So we were talking about the decomposition reactions. So very first thing, very stable compounds. They do not undergo decomposition. Very stable compounds like water. Water is very stable. They do not undergo decomposition easily. Just by heating, you cannot break down. Do not undergo decomposition. But which compounds are very stable? How will I come to know that the compound is very stable? Write another line. Very reactive metals or non-metals. If you're taking a reactive metal or reactive non-metal, they make stable compounds. Stable compounds. So it's difficult to decompose them just by heating. You'll find that their decomposition is very rare. So can you name some reactive metals? Which metals in the periodic table are most reactive? Which metal? Metals, alkali metals, meaning not sodium. Down the group reactivity increases, so you can say cesium. If we leave francium, which is radioactive, then cesium, make. Alkali metals are the most reactive metals. And what non-metals, girls? Amodita, non-metals? Most reactive non-metals? Non-metals are on the extreme right side of the periodic table. The most reactive non-metal is fluorine, but the family is halogen family. Yes, Amodita, you're right. So, halogen family is the most reactive non-metals and alkali metals. So, do you think it's easy to decompose NaCl by heating? Can I take NaCl and simply heat it to get sodium and chlorine gas? Answer is no. No, big no. You cannot decompose water by heating. You cannot decompose by NaCl by heating. Then what is needed to decompose them? Anyone? How can I decompose them? We are doing it. In the lab, we are doing it. How? So that you are going to learn in unit 9. You are using electricity. With the help of electricity, you are going to decompose it. Here also, electricity. Please understand, if very stable compound is there, then we are going to electrolyze them. We are going to do electrolysis, breaking down in the presence of electricity. Lysis means breaking down. Is it okay? Okay, fine. So let's understand different types of decomposition reaction, very popular decomposition reactions. This is not a popular one. I need electricity here. First, carbonates and hydrogen carbonates. What's the formula of carbonate? All of you, please type here. What's the charge on it? What's the charge on carbonate? Oh, no. Ananya? Yes. CO3 2 minus. What's the charge on hydrogen carbonate? Please have your this polyatomic ion list next to you. Okay, why I'm asking this to keep all the things on the table, keep looking. This is how we can memorize. You know, I'm the teacher, so I know that if you look again and again, I'm not asking you to memorize anything, but you look again and again, come in practice of searching things in the book, in the table. I've seen smart children, they are very good in searching things. You ask a question, if they don't know the answer, they don't sit quietly. They start searching here and there. Hydrogen carbonate, Akash, you're giving me carbonic acid. Hydrogen carbonate is HCO3 minus. Akash is giving me carbonic acid. This is neutral compound, carbonic acid. Carbonic acid, right? Okay. These carbonates and hydrogen carbonates accept alkali metals because they are very stable. These carbonates of alkali metals, they do not undergo decomposition. Rest all on heating. I'm talking about carbonates. On heating, except what? The one which are very stable. Except alkali metals. Because alkali metals are very reactive, so they make stable compounds. On heating, they give CO2 and metal oxide. Ready for one such reaction for the carbonate? And for hydrogen carbonate, I'll tell you about the hydrogen carbonate also. So CuCO3 is a solid. I'm heating it strongly. What's the product? Make metal oxide. Do not change the oxidation number. You know carbonate is 2 minus, so Cu is 2 plus. So make CO2 amodita, CO2 gas. Generally, decomposition takes place when some gas is formed. Carbonates, they can give CO2 gas on heating. CO2 gas, not CO3. And metal oxide, not copper 2 plus, not copper metal, metal oxide. So what's the answer? Yes or no? Yeah. What's the answer? Mank, perfect. Very good. This is solid. Metal oxide is solid. All metal oxides, all ionic compounds are. Remember this line? All ionic compounds are. All ionic compounds are. Yes, please. I gave you this line earlier also. Amodita, all ionic compounds are. They have very strong electrostatic forces of attraction. No, tell me the physical state. No, I'm talking about the physical state. All ionic compounds are solids. Yes, this is a popular line. All ionic compounds are solids. Of course, everything is neutral in nature. You don't have charges moving around you. Okay. El2 CO3 thrice solid heated. What's the product? Take care of the charges, Mayank. You know the charge on aluminum? Of course, one is CO2, but you have not made the right formula of aluminum oxide. Look at the periodic table. Check the charge on aluminum. Yes, Anaya, you are right. Al2O3. Yes, you are right, Amodita. And this is the solid again. Now balance the equation. So how to balance this equation? Can I put 3 here? That's it? Yeah, okay. Akash is giving us the balanced equation. So understood the decomposition of carbonate. One last. FeCO3. It's a solid ionic compound. Heat it. Can you give the metal oxide and CO2 gas is formed? Yes. Heat it. Yes, very good. Very good. You have very nicely you have taken care of the oxidation number of Fe because there is no change in oxidation number. CO2 gas. This is solid. And if I give you K2CO3, if I heat it, do you think I'll get potassium oxide and CO2 gas? Do you think this can undergo decomposition easily? I've written here, no. Stable, very reactive metal. Reactive metals, they make stable compounds. Stable compounds is hard to undergo decomposition. Is it okay? Okay, this is one example. Carbonates, one example. So please write down these examples. Then second is hydrogen carbonates. In fact, all hydrogen carbonates, all of them, they undergo decomposition, all of them. Like if I give you NeHCO3, sodium is a very reactive metal. This compound should be stable. But here the product will be slightly different. You will get sodium carbonate in this case. And water is formed. You're not getting CO2 gas here. Can you see water is formed? Is this equation balanced? Is it? No. Can you balance the equation? Because if I put 2 here, mhm, okay, put 2 here, then 4 hydrogen. That's wrong. Then I have to put 4 here, then I have to put 2 here, but then carbons are not balanced. So it means, okay, 1 second. Some CO2 is also released then. CO2. Yes. Is it balanced now? If I put 2 here. So some CO2 is also formed. Sometimes balancing will help us if we're doing some error. So this is for the NaSCO3, but for others, this is for alkaline metals. For others, the product is again oxide and water, like this one, this solid. You heat it strongly. What's the product? So you will get metal oxide and water in others. Because you know that carbonates, they are also undergo decomposition. So make this product metal oxide, water, and CO2 gas. Sorry, CO2 is also there. With the hydrogen carbonate on decomposition, they give us this product. Can you make now? Metal oxide, water, and CO2. Because all carbonates, they can further undergo decomposition to give us metal oxide and CO2. Yes. Check the charge on calcium, make its oxide, and balance the equation. Waiting for the answer, children. No answer? What happened, Akash? Calcium oxide, solid, plus, no. Metal oxide, see here I've written. What I've written here, Ananya? Because calcium carbonate, you are right that first you will get calcium carbonate. But we have just done that calcium carbonate can undergo decomposition to give calcium oxide and CO2. It's not going to stay as this. It will further undergo decomposition. Amodita, can we balance the equation now? Or is it balanced? I think it's not balanced. Should I put 2 here? Yes, now it is balanced. Yes, Akash, right. Mayank, do one more. Do the decomposition of FeHCO3 3 solid, heat it strongly. Remember, this is the general equation, metal oxide, water, and CO2. Take care. What is the charge on Fe? And accordingly, make your oxide. Mhm. What happened? Okay, what is the charge on Fe here? What is the charge on Fe? You know that HCO3 is 1 minus. There are 3 of them. So what is the charge on Fe, children? Plus 3. So when it's going to combine with oxygen to give metal oxide, what's the formula? Fe2O3. What's the other product here? So one is Fe2O3. Other one is these two. H2O and CO2. Balance the equation. I think you have to put 2 here, then 6 here, right? Take care of the hydrogens. 3 here. Check your oxygens. Are they balanced? Yeah, they are balanced. Oh, Akash has already given the equation. Very good, Akash. Meng, I'm not getting answers from you. Okay. Moving on, this is one type of decomposition. So decomposition reaction occurs when a compound breaks up either into elements or into simpler compound. Generally, a small gaseous molecule comes out, gaseous molecules like CO2, water. Look at this one. Decomposition of all ammonium. Write down this third category. All ammoniums. Ammonium means NH4 plus. On heating, their compounds. On heating, they give us ammonia, all of them. Ammonia gas comes out. And the smell of ammonia, you can feel the smell of ammonia. Ammonia has a very typical smell. And generally, a person, a chemistry teacher, or the person who is working in the lab attendant, they all know the smell of ammonia. If you go to fish market, there you can feel the smell of ammonia. Okay, so let's do the decomposition of ammonium chloride. So what is formed? Ammonia gas. What else? HCl gas. We have done this reaction, you remember? During effusion, diffusion, from one bottle ammonia is coming out. This is solid. White thick fumes. Rate of effusion and diffusion of ammonia and hydrochloric acid. We did this experiment. From here, ammonia is coming out. From here, hydrochloric acid is coming out. So they were supposed to meet in the center, but actually this is slow moving because high molar mass. This is moving with great speed. So ammonium chloride is formed here, closer to hydrochloric acid. We did this experiment, effusion, diffusion. So can I give you another example now? Ammonium bromide. Do the decomposition of this ionic salt. What's the product? Ammonia and HBr. Equation is balanced. Now I'm including the carbonates also. All carbonates, they undergo decomposition. Ammonium carbonate. So this time you're going to decompose ammonia. You're going to ammonium. You're going to decompose carbonate also. What's the product? Think about it and take care of the hydrogens also. Yes? Anyone? Carbonates, yeah, Mayank, but this carbonic acid will undergo decomposition. So the product is ammonia, CH2CO3, carbonates, they undergo decomposition to give CO2 and water. Like this, yes. Balance the equation. Is everything okay? Yeah. You're understanding this, children? Yes. Then fourth category, chlorates. Chlorates, perchlorates, they are rich in oxygen, very rich. So chlorates, they give O2 gas on heating. Very popular reaction, KClO3. I think I told you how to collect oxygen gas by the downward displacement of water, the moist gas during this your Dalton's law of partial pressure, vapor pressure of water, how to collect gas by doing downward displacement of water. I was showing you a picture. In that picture, there was KClO3, and you were heating the KClO3, heating, and is undergoing decomposition to give you ionic salt and O2 gas. The product is ionic salt. So, what is the ionic salt here? KCl, solid. And what else is formed? O2 gas. Then we balance the equation. Put 2 here, 3 here, 2 here. Mayank, am I right? And you are wrong? Yes, Mayank. Now, children, can you do the decomposition of MgClO3 2? Solid. Complete the equation and balance it. I want answer from all of you. And then do this one also. And take care, ammoniums, they also undergo decomposition. Yes, Anaya, good. Mayank, good, but you didn't balance the equation, both of you? Or is it balanced? Now it is balanced. Yes, Akash. Good. Now do this one. And don't forget ammonium chloride, which you are expecting to get formed, will undergo decomposition like this. So double decomposition. First, ammonium and chlorates, they undergo decomposition. Then ammonium chloride will undergo decomposition. Give me the final product. Double decomposition, children. Mhm. Mhm. Okay, Mayank is giving us very good answer. Is it balanced, Mayank? Because you are getting ammonium chloride, Ananya. And ammonium chloride, they undergo decomposition further to give you ammonia and HCl. That's why. Because first, it will undergo decomposition to give you ammonium chloride and O2. If you balance the equation, you have to put 2 here, 2 here, 3 here. Then this ammonium chloride further undergo decomposition to give you 2 ammonia, 2 hydrochloric acid, and 3 O2. Yes. Okay. Okay, so these are the decomposition reactions. I can keep telling you many more, but generally we have very high tendency of forgetting about that. So whenever a new type of reaction will come, I'll explain you again that what category of reaction is this. Two last examples. You remember peroxides? Peroxides, they also undergo decomposition to give you metal oxide and O2 gas. They all, like for example, Na2O2, heated strongly. What is formed? H2O2, heated strongly. What is formed? Metal oxide, sodium oxide. What's the formula of sodium oxide, children? Na2O plus O2. Balance the equation. So you have to put 2 here, 2 here is balanced, correct? H2O2. Do the decomposition of H2O2. Of course, there is no metal, but hydrogen is just like alkali metals. H2O2, children. Yes, Akash, you're good. H2O2, Ananya and Amodita. Yes, H2O plus O2. See, many teachers, they also forget about these reactions. But they are very easy to memorize, easy to understand. Like Na2 peroxides have plenty of oxygen in them, plenty and plenty. So they undergo decomposition to give oxygen gas. Carbonates have plenty of CO2 gas. CO2 gas is formed. Like azides. Look at your polyatomic ion list. Can you give me the formula of azides? Azide. Yes. So what do you think? These azides, when they undergo decomposition, what can be formed? Yes, yes. What can be formed? We did one question in this ideal gas laws about car bags that during accident in the car bag there is sodium azide. So under the impact of force and heat, sodium azide will undergo decomposition to give on heating. This is very unique reaction because this is very unstable. Yes, not N3, Mayank. There is nothing N3, N2, N2 gas, 3N2. This is solid. It's not going to react because it doesn't react with nitrogen gas. It's very reactive metal, but it's not going to react. So this is a decomposition reaction. You're getting N2 gas. Similarly, nitrates. What do you think? Nitrates can give you which particular gas? Nitrates, NO3 minus. Which gas can come out on heating? Yeah, NO2. Very good, Mayank. And this NO2 gas is brown in color. Brown. You can see. You take any nitrate like copper nitrate, you heat it strongly in the test tube, take solid. After some time, you can see this brown gas is coming out and it will get converted into CuO plus NO2 gas. You have to balance the equation. Is it balanced? Nitrate. There is oxygen also liberated because there is a change in oxidation number here. So some oxygen is also coming out. Now, can I balance the equation? 2, 2, 4. Is it balanced now? Just check the oxygens. Yeah, it is balanced. So you are understanding this, children? I'm going slightly faster here because AP is not testing you for this. This is just for chemistry Olympiad. AP will not be testing us much about it. So I just want to show you the similarity, the meaning of the decomposition. So moving on. Oh, this is another very important thing about decomposition reaction. Can you list some metals from the periodic table which can occur as such in the pure form, like not in the pure form, not combined with the other like oxygen, nitrogen, some metals, unreactive metals, noble metals? Yes, silver, gold, mercury, platinum. These are unreactive metals. They are used in, yeah, okay. They are used in jewelry, titanium, yes. So what happened when they form compound like this mercury oxide? Unreactive metals, less reactive or unreactive metals, they form very unstable compounds, easy to break down. Unreactive metals, metal compounds will give you metal on decomposition plus whatever is the other part, plus some gas or something, whatever is there. Like this is an oxide, so oxygen gas. If I give you HGS, then on decomposition, what I'm getting? Yes, Hg and sulfur coming out easily. Even if I give you HgCl2 on decomposition, what I'm getting? Hg and Cl2 gas. Cl2 is a gas, right? Mercury is solid liquid gas. Mercury. All metals are solid except mercury at room temperature. It's a liquid. Sulfur is solid. And if I give you Ag2O on heating, what I'm going to get? Silver and O2 gas. Okay, so all these are very popular reactions which we must know as a chemistry student. Decomposition reactions. Okay, so I have already explained you all these. Carbonates, they give you which gas? Yes, please. Carbonates, CO2. Chlorates, chlorates. All chlorates, they undergo decomposition to give O2. Peroxides, all peroxides, they undergo decomposition to give peroxides, O2. All ammoniums, they undergo decomposition to give ammonia. All azides, they undergo decomposition to give azides to give, yeah, good. It's interesting chemistry, isn't it? Okay, moving on. Combustion reactions, we already know. What is combustion? Combustion. C4H10. Yes. So if I say combustion of this compound, what is the other reactant? O2. What is the product? Yes, Amodita. Very good. Perfect answer. Balance the equation. Remember, I told you not to touch O2. You can put a fraction in front of it. So, give me the balanced equation. We did this in Unit 1, empirical and molecular formulas. Yes. Why are you taking so much time? Balance your carbon, balance your hydrogen, check your oxygen, put 13 over 2 here, get rid of this 2. We did all these things earlier. Get rid of this 2. So 2, 8, 10. Yes. Very good. Very good. Mayank, Ananya, very good. Perfect answer. So I'm skipping this combustion reaction. Now this is representation of reactions, and if this white is hydrogen, black is carbon, this red is oxygen. Can you tell me what are the reactants? What is the reactant? CH4 and O2, giving you what is this product? Can you see it's linear? Yeah, CO2, remember it's linear. And what is this? So can I say it's a combustion reaction? It's a combustion reaction, right? Okay, and what is the shape of this molecule? Tetrahedral, yeah, see. And this one? Bent, good. Okay. Now, single replacement reaction. I'm just going to give you the introduction, and more you will learn later on when we are going to do redox reactions. In single replacement reaction, more reactive. They will ask you to memorize a reactivity series, but AP is not asking. More reactive element can displace or can kick out, can displace less reactive element, like more powerful person can kick out weaker person from his chair, from his position. This is the game of the word. More reactive element can displace less reactive element, or you can write down kick out less reactive element from its compounds. So ready to understand this? So you know halogens are very reactive nonmetals. So what is the order of reactivity of the halogens as you move down the group? Which one is most reactive? Which one is least reactive? Yes, very good, Ananya. Very good, Mayank. This is most reactive because as we move down the group, size increases, tendency to gain electron decreases, non-metallic character decreases, so they become less reactive non-metals. Akash and Amodita, you heard the words? Very soon I'm going to make a video on periodic trends. I share the link. You must watch it. Okay? Because periodic trend is something which is very important to stay with chemistry. Okay? Now, if I give you fluorine gas with NaCl, now you know that fluorine is more reactive than Cl. So what will happen? So I have taken aqueous here. What will happen? This fluorine will kick out Cl as Cl2 gas. Yes, Anaya, very good. Cl2 gas. And what is formed? NAF. Aqueous. Perfect. Cl2, Mayank. There is no Cl, okay? We cannot have Cl. Do you think we can have Cl? Cl is very reactive. Okay, if I give you Br2 liquid with NaI aqueous, what is formed? What is formed? NaBr aqueous and I2 solid. I2 is solid. Remember, IMF increases down the group. They all are non-polar. They all have LDFs. And LDFs increases with the increase in size and molar mass. Now let's see this one. I2 solid. Okay, let's not take solid. Let's take Cl2 gas with Kf. Do you think this reaction can take place? No, no reaction, no change. That means Cl, we already know Cl is less reactive than fluorine. So Cl cannot kick out fluorine from its compound. We are good with this? Now, I'm taking you on the next example. The next example is alkali metals. Do you know the reactivity order of alkali metals? Reactivity order. Which one is the, just leave hydrogen, which one is the least reactive, which one is the most reactive? Lithium, sodium, potassium, rubidium, cesium. Very good, Mayank and Amodita, perfect. Lithium is least reactive. You know the reason? Size increases, tendency to lose electrons increases, ionization energy decreases, and metallic character increases. They become more metallic. They are more happy to lose electrons. Okay, that's the order. So let's see the reaction. If I give you potassium reacting with cesium iodide, aqueous. This is solid, it cannot be aqueous. So what's the reaction? Is there any reaction? Yes or no? Or if there is any reaction, complete it. No reaction. Very good. No reaction. No reaction. But if I give you cesium solid reacting with KCl aqueous, what's the product? Yes, cesium chloride, aqueous, soluble, and K solid. So it's a big chemistry. Single displacement. This is single. In single displacement, more reactive element like A is displacing B from BC, right? And here A is displacing C. A over here, A is metal because it's first. See here, it is first. First are always cations, so that's why they're saying A is a metal. Here, A is second. Second is always a non-metal, so that's why they are saying A is non-metal here. So the reaction is there with metals as well as non-metals. If I say zinc is more reactive than copper, so there is zinc metal and there is copper sulfate, aqueous. Aqueous copper sulfate is blue in color. They say after the reaction, the blue color disappears. Can you give me the products? Zinc is more reactive than copper. Zinc sulfate, very good, Mayank. And copper solid. You can see copper solid coming out as brownish metal, reddish brown metal. And this is colorless, no color. So there is a change in color, blue to colorless. So it means reaction has happened. So these are single displacement reactions. Now I'm coming on the next category, double displacement reactions. In double displacement reactions, you are going to learn precipitation reactions and acid-base reactions. They fall in this category. Okay, so what is a double displacement reaction? In double displacement reaction, we are not worried about the reactivity. We are just going to interchange all the ions. Like for example, if I give you AgNO3, which is completely soluble, NaCl, which is completely soluble, it will give me, now do the double displacement. Don't worry about reactivity. This is Ag plus, this is nitrate minus, Na plus, Cl minus. Interchange cations and ions. What's the product? AgCl. This AgCl is not soluble. It will come out. And NaNO3. This is soluble. This is double displacement, children. Reaction has taken place because I can see this solid coming out. But the question is, how do you know it's solid? So we are going to do solubility rules just now after this. If I give you HCl and KOH, what's the charge on H? What's the charge on H? Cl. K. What's the charge on K? OH. K has plus, OH is 1 minus, right? Can you do the double displacement? This H plus will go to OH minus and will form water. And this K plus will go to Cl minus to form KCl. See, this is acid-base reaction. Water and KCl. Yes, Mayank. Good. Akash, good. They are soluble. This is acid. We know that. This is base. We know that. Acid base, they react to form salt, ionic salt, and water. It's also called as neutralization reaction. It is also called as double displacement and is also called as acid-base reaction. 3 names. Is it okay? Okay, so let's start with the very first category, precipitation reactions. So I'll make you understand the word precipitation reaction. Okay. First, I'm going to make you understand the word precipitation reaction. There was a clear solution. You can see this is a clear solution. Clear. No solid. This was earlier a clear solution. No solid. When you mix these two clear solutions, clear, they are completely soluble before reaction. When you mix them, some solid starts coming out. We call it as precipitation reaction. Right? You're understanding this? Precipitation reaction. And now your next topic starts. Precipitation reactions, net ionic reactions, meaning of electrolytes, weak electrolytes, strong electrolytes. So first I'll make you understand the word electrolytes. Electrolytes are the substances. When they are dissolved in water, they form ions. ions in water. They are electrolytes. But then these electrolytes are divided into two categories. First, understand all acids, all acids, all bases, and all ionic solids, all of them, ionic compounds. They are electrolytes. When you put them into water, they dissociate to give ions, right? But then they are further divided into two categories. Weak electrolytes and strong electrolytes. For strong weak electrolyte, I will be writing We. For strong electrolyte, I'll be writing Se. Now, what's the meaning of weak and strong? Weak is not fully dissociated, not fully dissociated in water. It's not going to give you a large amount of ions. So number of ions, the ions which are formed are less. Check here. Let's say this, you can see this molecule. Let's say this is HF. This is HF. Is this dissociated right now? It's an acid. Is it dissociated? No. This one? No. This one? No. 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 But one molecule is dissociated. One. Can you see one molecule? So here the dissociation in HF is less or more? Is it less or more? Very less. It's not fully dissociated. It's giving you less amount of ions. That's a weak electrolyte, HF. I've given you the list of weak acids earlier, remember? No? Weak acids and strong acid. Okay. Okay, let me give you that list here because we'll be using it a lot every time. I'm giving you solubility rules also. Okay, check, take these solubility rules. Oh, sorry, not this one. Not this one, please. Can I delete this message? No? You can use also this one, but I'm giving you the one which is made by me. This one. This is from the book. These are the solubility rules. Now I'm giving you a list of the acids and bases. Okay. So now please understand, all weak acids are weak electrolytes. All weak acids. are weak electrolytes. They are not fully dissociated. All weak acids. For the weak acid, I'm writing WA. All weak base and all ionic compounds which are less soluble. Ionic solids which are less soluble. Their solubility is very less. They are slightly soluble, less soluble. The one which has tendency of precipitating out. They all are weak electrolytes. They are not fully dissociated. So you have the list, children. Can you tell me all carbon containing acids are weak or strong? All carbon containing acids are weak or strong? Just read the list. Yes. If I give you HCN, is it a weak acid or strong acid? HCN. Acids, they start with hydrogen. We have done the nomenclature earlier. So HCN is a weak acid or strong acid? Mhm. Come on, Mayank. Is carbon containing acid? Is carbon. Can you see carbon here? All carbon containing and phosphorus containing acids. You tell me, Anaya. Anaya is saying, is carbonic acid strong, H2CO3? Yes, what do you think, Anaya? Is it strong or weak? Anaya. Is carbon containing acid strong, weak? Weak, yes. And these are weak acids because they are not fully dissociated. They will dissociate like this, the way small one molecule is undergoing dissociation in 100, like this. They are weak acids. If they are weak acids, they are weak electrolytes or strong electrolytes. Okay, Amodita, what's the confusion? And what's the meaning of question mark? Anaya? Amodita, you are saying strong. Who is strong? All carbon containing and phosphorus containing acids are weak acid. So it means they are weak electrolytes. What do you think for H3PO4? Strong, weak? Weak. Is a strong electrolyte, weak electrolyte? Is it a strong electrolyte, weak electrolyte? Weak electrolyte. So it means it's not 100% dissociated. I try to understand the meaning of weak here. Weak acids, they are not fully dissociated. They are weak electrolytes, right? Now let's see what is strong electrolytes. You have the solubility rules. Can you tell me from the rule number 1 of the solubility rules, is NaCl completely soluble compound in water? NaCl? Rule number 1. Yes, it's a strong electrolyte. Is going to dissociate completely in water as Na plus 100% dissociated, 100% dissociated, giving you a large amount of ions as Na plus aqueous and Cl minus aqueous is soluble. Can you check rule number 2? Can you tell me, is this AgBr soluble or not soluble? Is it going to dissociate 100% or is it slightly dissociated? Check rule number 2. Rule number 2 is saying chloride, bromides, iodides of silver plus, Pb2 plus are not so soluble. Am I right? Akash, are you checking rule number 2 for the solubility rules? Yes, children. So is it soluble or not soluble? This one, not soluble. But it's an ionic compound which is less soluble. So it's a weak electrolyte. It falls in this category, AgBr. Because it's not going to be totally 100% dissociated. It will dissociate, but to some extent, that's it. Rest all will remain as solid, will precipitate out. You're understanding my language, children? Akash, Amodita? Okay. Now let's check. HBr. Check your list of polyatomic, strong acids and weak acid. HBr, strong acid, weak acid. There are only 3 non-oxo strong acid. HBr, HCl, HI. Rest all are weak, only these 3. Strong acid means, what is the meaning of strong acid? That they are 100% dissociated. And they are strong electrolytes. Good. Please understand this word, 100% dissociated. Strong electrolytes. So these falls in this category. Are you understanding the word weak electrolyte, strong electrolyte? Check this picture. Is there any molecule which is undissociated? Like in this picture? So this is a strong electrolyte. This is a weak electrolyte. Do I have any ions here? Any ions in this picture? It's a non-electrolyte. Non-electrolyte. I didn't cover this topic, non-electrolyte, yet. So I was working with strong electrolytes and weak electrolytes. What are non-electrolytes? Covalent molecules. They do not break down into ions. Maybe they are soluble, but they don't break down into ions, right? Covalent molecules. What do you think, sugar? Is sugar soluble in water? So is sugar going to break down into ions? Formula is this one. No. So sugar is not going to give you ions in water. It's a non-electrolyte, right? Can you check now on the top what is happening? A strong electrolyte is very strong conductor of electricity. A weak electrolyte, slightly. The bulb is still glowing. And a non-electrolyte is a non-conductor of electricity. Why is it so, Amodita? What is the reason? I think I told you this when I was telling you about the ionic solids and all these things. For conducting electricity, what is needed? Oh, Mayank, that's very wrong language. For conducting electricity, who is going to correct Mayank? He's using very wrong language. Please correct him. For conducting electricity, we need moving charged ions. If you have free moving charged ions, like in strong electrolyte, there are plenty of them. Weak electrolyte, some of them. So more moving charged ions, more better conductor of electricity. Akash, you're right. But why Mayank is wrong? Yes, anyone? Mayank, where are free electrons? Am I showing you any free electrons? With NaCl, do we have free electrons here, Mayank? So NaCl is a good conductor of electricity in water, not because of free electrons. It is a good conductor of electricity because it's a very strong electrolyte. It's going to dissociate 100% into water. So who can conduct electricity due to free electrons? Who can conduct? Matters. So do you think matters are electrolyte, Mayank? Yes, children, matters are electrolyte? No. They don't dissociate into ions in water. They are solid, they will remain as solid only in water, but still they are good conductor because of the presence of free moving electrons. But they are not electrolytes. Mayank, you have understood your error? Okay, children, are we clear about electrolytes, weak electrolytes, strong electrolytes? For the weak electrolytes and strong electrolytes, you are going to use your solubility rules and you are going to use your strong acids and weak acids, strong bases and weak bases concept. Moving on. Check. Check all the pictures. They have given the names also. So this is HCl container. Can you tell me the formula of this compound? This one. It is actually difficult to see, but I'm giving you HC2H3O2. It's an acid. Yeah. There are 4 hydrogens, not 6. Can you see? 1, 2, 3, and 1 on the oxygen here. 4, not 6. But you can see this compound in your polyatomic ion list in carbon. Check what is the name of this compound. What is the name of this compound, children? Yes, acetic acid. Acetic acid from acetate ion. And this one is hydrochloric acid. What is this compound? This one? Sodium hydroxide. What is this one? This one. Oh, come on, Mayank. What are you doing? Look at the picture, the color code. What is this? It's NH3, this one. What is this? It's NH4 plus. What is this? It's OH minus. So basically it is ammonia in water. I'll explain you. Okay, now out of these pictures, which two are very strong electrolytes? And this is acid. And this is a base. What is a base? A base is the one which can give you OH minus in water. Can you see it's giving you plenty of OH minus, 100% dissociated, 100%. Now what about the rest two beakers? Are they strong or weak? So this is weak acid. Carbon containing acids are weak acid. Can you see hardly one dissociation? Only one molecule is dissociated. And this is also, can you see OH minus are generated, but only very less amount? So this is a weak base. Ammonia is a weak base, a weak electrolyte. Ammonia is a weak electrolyte. Acetic acid is a weak electrolyte, weak acid. HCl is a strong electrolyte. NaOH is a strong electrolyte. We're okay? Moving on, children. So what is a non-electrolyte? Which is not going to dissociate into ions. And who cannot dissociate into ions? Covalent molecules. Covalent molecules. CO2. Is it electrolyte or non-electrolyte? It's non-electrolyte. And they cannot conduct electricity because you don't have moving charge particles. C6H12O6. Electrolyte, non-electrolyte. Non-electrolyte. I2, non-electrolyte. Okay, so now you can easily identify weak electrolytes, strong electrolytes, non-electrolytes. Molarity we have already done in the last class. So what is molarity, children? Molarity means, okay, moles per liter. Yes. So can you calculate the molarity of A solution? Is A a solution? Can you see how they are settled down at the bottom? Is it soluble? No. So you cannot calculate the molarity of A, right? Let's calculate the molarity of B. B is a solution. If I take them as moles, 1, 2, 3, 4, 5, 6. So the molarity is 6/4. Yes, 1.5 molar. So similarly calculate for this C solution, please. 2 molar. D solution, 3 molar. So which solution is the most concentrated one? But can you see that number of particles here? 1, 2, 3, 4, 5 is 6 here, right? Here also 6. But how come this is more concentrated? Because it has exactly half of the volume. This is 4 liters and this is 2 liters. So volume is very important. So if volume is high, if you increase the volume, what happens to molarity? Molarity will change. Will decrease, yes. And if you increase the amount, what happens to molarity? It will increase. So remember that if you change the moles, if you change the volume, molarity changes accordingly. We did molarity and dilution law also. You remember the dilution law? You are adding water. I told you how to make a standard solution. So what is dilution law? Yes. You take your concentrated solution, you add only water, nothing else. You get diluted solution. Diluted means, concentrated means, what is the meaning of concentrated? High molarity. Yes, oh yeah, Mayank, very good. High molarity. And diluted means low molarity. Let's see this picture again. This one. C, B and D. How many moles are here? 6 in 4. How many moles are here? 6 in 2. If I want to dilute this solution up to here, what should I do? I add, you double the volume. Yes, you add 2 liters of water. But when I'm adding water, add water. That's what you want to say. Add 2 liters of water. So when I'm adding water, is this 6 changing? The moles are changing? No. So remember this equation that during dilution, the number of moles before dilution and the number of moles after dilution, they remain same. No change. So what does it mean? It means that moles, these are moles. Before dilution, after adding water, moles after adding water, after dilution are equal. They're equal. No change. Because you are adding water only. So moles can be calculated by M1 V1. This is the molarity and volume before dilution. And this is the molarity and volume after dilution. Molarity will change, volume will change, but moles will not change. And this is the dilution law. Ananya, is it clear? Amodita, Ananya? So please remember this line. We can memorize the equations, but we should know the reason also. Okay, ready to do this question? A part. Mhm. You can say this is M1. Now I want to convert this molarity to 0.50 molar. You know, this is called as fuming acid. Very harmful. You have to be very careful when you are dealing with it. Fuming. I've heard many accidents in the labs just because of this acid and hydrochloric acid. 16 molar. Very concentrated. Yes, how to do this question? Can I say this is M2? This is V2? They are asking me to take this acid and make a solution of this molarity in this much volume. So I can use this equation M1V1 equals to M2V2. And don't worry, okay, this is in liters. Okay, good. Then you can do that. 18 times V1 is 0.50 times 1.00. Take care, you should have your answer in two significant figures. So V1 is, how much is V1? 0. How much is V1, children? 0.028 liters, which means 28 ml. So you will use a flask, round bottom flask of 1.00 liters. First, you add water. You remember I told you this precaution. Add water to some amount, let's say half. Now in this pipette, or you can use a cylinder here, measure 28 ml. Add that 28 ml and then you rinse it also with water. Means with take some water in this test tube also finally, so that to remove all the acid. Add here. Now you're using, add more water, come up to this level, use a dropper, add drop by drop. Your eye should be here and get the level. Okay, you remember I discussed this in detail, very in much detail form in your unit 3. Amodita, do you remember that? Making of the standard solutions. Because I'm teaching so many children, so, but I remember we did molarity in unit 3. Can anyone confirm? Yes, we did. Okay, good, Amodita. So please remember, always add concentrated acids, bases, in H2O. Don't do other way around. Don't take acid and add water. The solution will jump out. The mixing is very exothermic and so much heat is generated that it will make solution to bump out and it can harm us. So, and be very careful. Your eyes should stay away. You should be, when you are making this solution of concentrated acid, when you're doing it, your face should be away from the container. Are we clear? Ananya, any questions? So you're going to take 28 ml and in 28 ml, you're going to add 972 ml of water, but you are not measuring it. You have taken this 1 liter volumetric flask, you have taken some water, you have added 28 ml drop by drop into it, and then you are adding water coming up to this mark. And your solution is ready. Can we do the next one? So this A part is based on dilution law. What about this? You want to make this solution. Very popular questions, making of standard solutions. They have given you solid. So you're going to dissolve this solid in 1 liter. You'll take a 1 liter volumetric flask, you'll dissolve solid. Question is how much? How much solid should I take? Can I calculate? So I'll get the moles of Na2CO3, sodium carbonate. How? Yes, children? How can I get the moles of sodium carbonate? Okay. So rearrange it. Yeah, start using this equation, girls. This one. The equation which Amodita is giving us, we can rearrange it like this. So you should come in the practice of using it. Straight away you have to tell me this equation. Molarity is 0.50. Volume is 1.00. So it is 0.50 moles. Can I convert these moles into grams? How? Moles to grams. Oh, no, Anaya. I'm not going to divide. Yes, be sure, divide or multiply. Multiply, okay? Because you know this equation, that moles equals to, start using this equation also, because every time we cannot be dependent on dimensional mass over molar mass. You know this equation very well, right? So mass is, I'm asking you mass, is N times molar mass. Start using this also, it's faster. Dimensional will avoid these errors, what Ananya is doing right now, divide or multiply. Dimensional straight away will tell you what you have to do. But Mayank, did you calculate the molar mass? Because without molar mass, I just don't know. Did anyone calculated the molar mass? Because I'm not interested in the answer. I'm interested in the method. 0.50 multiplied by the molar mass. Is it 108? Oh no. Is it 83? No. So Mayank, how come you're getting 41.5? Is 106? Again, I think this error you did last time also. You have not taken 2 sodiums. You have taken 1 sodium. And this is the answer. Mayank, I think you have taken in your molar mass 1 sodium. So, two significant figures. How many grams? 53 grams? Two sig fig. Yeah, 53.01 gram. You can measure it, right? By using weighing balance. You can go up to 4 sig fig. You want to make very accurate standard solution. You can go for it. Then explain the procedure. Yes, please. Explain how to make it. We'll take a volumetric flask of 1 liter. You add your 53.01 gram here, the solid. It's not a strong acid or strong base, so don't worry, you can add it first. Then you start adding water. It has a mark. Add water. Shake it properly. Add this much water. Dissolve it. Keep adding water. Reach up to this level, very close to this mark. Use a dropper. With the help of dropper, now start adding water drop by drop. Your eye should be at the level of this mark. Once the water touches this meniscus, stop adding water, shake it properly, close it, and your standard solution is made. Standard solution. What's the meaning of standard solution, children? Yes, Mayank, very good. See, this is the, okay, 1 second. This is the mark. When you are adding water, water is making a meniscus. The lower meniscus should be touching, not the top, the lower one, like this. This part can be up because water is showing capillary action. You remember surface tension, capillary action? We did in unit 3 with liquids, viscosity, surface tension, capillary action, cohesive forces. Cohesive and what was the other name? Cohesive and the other one was? You're not revising things properly. So start looking. I've given you notes. So those notes are based on my teaching only. So you take a printout, make small booklets. Just keep scrolling those pages. So anytime when I say something, unit 3, just pick up that unit 3, just keep flipping the pages, see what she's talking about. Try to think, try to work out the answer. Stay very active in the class. Is it clear, Amodita? Lower meniscus? Amodita. Okay. Good. So, and your solution is made, standard solutions. Okay. Now we have already started doing solubility rules. Can you write down one more thing here? Chromates. CrO4 2 minus. Add them also. They're also least soluble, least. So I'm giving you a brief idea about the solubility rules so that you can practice. There is no need of memorizing. You need to memorize for your AP chemistry. Rule number 1, rule number 5. But you will find that these rules are not difficult to memorize. See here. When I say soluble, then that ionic compound is a, why we are learning it? Because when I say soluble, then ionic compound is a strong electrolyte. You remember? Means 100% dissociated. Agreed? And when I say less soluble means it can come out as solid easily. Then you say, what is it? Less soluble ionic salts are? Yes, Mayank? Akash? Yes, they are weak electrolytes, not fully dissociated. Fully means 100%. They are very less dissociated. Akash, you're there? Okay. Now, let's practice these solubility rules. We are left with very less time, but I can make you understand. As you're going from rule number 1 to rule number 6, solubility is decreasing drastically. Like you can see this gap, this one, rule number 1, 2, 3. They are always soluble. All the compounds are soluble except few. Those few are listed here. And you'll surprised to see rule number 1 is soluble with all compounds, everything. You see this first group cation, soluble, whatever it is. You see this ammonium, soluble. Acetate, soluble. Nitrates, always soluble. Hydrogen carbonates, soluble. Perchlorates, soluble. So they are always soluble with anything. But as I go to rule number 2, can you see these cations? 4. They are not soluble. In this copper 1 plus, not copper 2 plus, copper 2 plus is soluble. These are, you can see 1, 2, 3, and 4. Chloride, bromide, iodide. Yes, Akash. All acids are soluble. Okay, Amodita is asking a question. Why these are not soluble, the other one are soluble? What is the reason? Remember solubility, Amodita. Solubility is not free. It needs energy. Remember the solubility can be exothermic, endothermic. It depends on delta H lattice, solution making, and delta H of hydration. We did this equation in unit 3. Delta H solution is this. Lattice is endothermic. Hydration is exothermic. When these energies are compatible, when the energy needed to break the lattice, energy released when hydration is happening, when they are nearly same, then they are very soluble. Yes, Akash, you're right. Amudita, you got your answer? Everything what is happening is based on energies. Like I don't have money, so I cannot go to a big restaurant, to a 5-star restaurant. I cannot have luxurious life. Whatever I do, I won't be able to touch the such high luxury because of the less money. But if I do have money, I can have all luxuries, right? So understand this. Same here. Energy exchange. If energies are compatible, energy needed, energy released, if they are nearly same, yes, that thing will happen. Otherwise, no. Are we clear? Okay, children, I think I should continue with these solubility rules in the next class. So we'll start from here. Next class is very important. I will start exactly at the same time. We'll start with the rules. So please don't miss. So join the class before the time, 2-3 minutes before the time. See you then. If you have any questions, you can stay back. Yes, Mayank. What's your question? You can speak. Okay, Mayank. Many students are asking for it. And like every year, I'm getting requests from many students, please start organic chem videos. I have not started yet. I'll start. Most of my time is going in teaching. So I don't get time. Throughout the year, I'm teaching only. I get hardly some hours of sleep and then some hours for doing my household work. I'm a housewife also. I'm a mother also. I have to do cooking. So, but yes, yeah, I teach organic chemistry, man. Organic chemistry is my favorite. I love organic chemistry and I teach organic chemistry. If you want, I can start for you. But for the organic chemistry, I'm taking only one-to-one classes. One-to-one, not in the group. Okay? No, Mayank, I don't have batches of organic chemistry because organic chemistry students, they are from different parts of the USA, from different colleges, and they come according to their requirements. So there is no group. It's one-to-one learning, one-to-one class. Okay, bye.